All right, we're gonna try and finish this up. I ran into some technical difficulties. Apparently, there's only so much memory on my Chromebook or whatever to record a video. 55 minutes seems to be the limit. So we'll finish this one up. This one's kind of weird. Um, so H7, by the way, so H6, if you plug, this function just equals 0. So H6, this works up to 6. So that's just 0. But then after H7, we want to figure out, well, how much has gone into 7? This is the function for the total because we integrated everything. So if you plug 7 into that, you get 125. H7 equals 125. And then you go from 7 to T of the last rate that's applicable for 7 to 9. And so then we get 125. We integrate this. Anti-drill is pretty easy. So even though we have a calculator, we're actually trying to find equations for these. So this is going to be 108t minus 7 times that 756. This was going to be what, 125t minus 600, 750. I mean, I don't know if we really need to do that now. This is good from 7 including 7 to 9 including 9. Now, I've just done all this work to prep it because it said to write a piecewise function. So we're going to write a piecewise function. All that was just kind of get ready from. So 0 from t to 6, 125t minus 750 from 6 to 7. And then what does this end up being? 125, 136 minus 108t minus 631 from 7 to 9. So that's your piecewise function. 1 point for each piece. So that was kind of strange. It's kind of tough. And then D says, how many cubic feet of snow are on the driveway at 9 a.m.? So this was just how much snow had been removed. So at 9 a.m., we want the amount of snow at 9, which is going to equal the amount of snow that was there at 0 plus the amount of snow that's fallen, 0 to 9 of ft/dt, minus how much has been removed. And that's what we just found. Essentially, we should say this is H9 because this is the function for how much snow had been removed. That was complicated. So this is where we could use our calculator to calculate this. And let's see, I think I still have this equation in my Y menu. Looks good. So from the home screen, I'm going to do math 9, bars y bars function y1, comma x, comma 0, comma 9. Snow started falling at midnight. Get that answer. $367.334606. And then H9 means we got to use this chunk right here. We got to plug 9 into that. So 108 times 9 minus 631, all subtracted. And I mean, we could just do this all at once. We could just say, all right, minus parentheses 108 times 9 minus 631. And hopefully we've done everything right. And we get 26.334606. So the answer is 26.33, now 4, so 3 decimal accuracy in general, cubic feet of snow are on the driveway at 9 a.m. All right, got that one done. And so we have one last one, which brings in some other topics that a couple tests ago. We have a table right away. When you see a table on a free response problem or any problem, probably, but we're going to be using estimation techniques. Probably not going to actually have functions. So we're going to do like trapezoidal approximations or rectangles or finding slope between it, 2 points. So it says concert tickets went on sale at noon, so that's time 0, and were sold out within 9 hours. And this table goes from 0 to 9. So the number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L from 0 to 9. Twice differentiable means second derivative exists everywhere, which means the first derivative is continuous and exists everywhere, and that means the original function is continuous and exists everywhere. Differentiability requires continuity. Values of LT at various times t. So this is the number of people in line tickets is modeled by. So this is the number of people in line at a certain time. Use the data in the table to estimate. So you're always going to do estimates with these tables. The rate at which the number of people waiting in line is changing at 5:30, 5.5. Show the computations that lead to your answer. Indicate units of measure. So 5.5 is right here, somewhere in there. And so we don't have an actual function to take the derivative of. We're trying to find the rate. And so we're going to just do a slope of a tangent line between these points, closest points. And so that's often a very common thing to have to do from a table. So we're estimating the derivative of L at 5.5. And we're going to say, well, it's like rise over run from 4 to 7. So it's good to show your work. Rise over run, change y over change x. In this case, change in L over change in t. Show the setup. We can look up those values in the table. We could get 24 over 3, which is 8. The units are, and they said indicate units of measure. This problem is worth 2 points. I could see it being worth 1 point, and if you don't put the units, you lose the whole point. But at least if you don't, 1 point's for the units. The units are, this is change in L over change in t, so it's change in people per hour. And this is an approximation. All right, so that's common from the table. That's not really rate model yet so much. B, use trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line for the first 4 hours. So we're only using this chunk of the table for this. 3 subintervals. Okay. And we're going to use trapezoids to help us find the average number of people. So this is average. That's mean value theorem. So F average is, in this case, L average. And that we're not taking the average of the derivative. So this is, I don't know if you guys remember it, we find if you take a curve and you smooth it out, that leveled out height is the average height, the average output of the function. So the way we get it is we integrate the function from 0 to 4 and find the area. We smooth out the area. It looks like a rectangle now, and we divide it by the base of the rectangle to get the height of the rectangle. So this is your setup. Hopefully you don't have to memorize it, and we could think it through. You got to write that down. That's setup. It's probably worth some points. So it's 1/4. Now what we have to estimate is this. So I'm going to draw a quick picture because I just find it helpful. 0, 1, 3, 4, 3 subintervals. 120, 156, 176, and 126. And we're doing trapezoids. So we're connecting the endpoints and we're finding the area under these. Now, this is the height. They're sideways trapezoids. And so this is approximately 1/4. And so the area of a trapezoid is the average of the bases times the height. It's like the area of a rectangle, base times height, but there's two bases, so you average them. Average of the base is 120 plus 156 over 2 times the height plus 156 plus 176 over 2 times the height plus 176 plus 126 over 2 times the height. So you want to show that you're doing trapezoids. The picture isn't going to give you any points, but you need to show that you're doing the area of trapezoid. We do have a calculator, so I mean, we could just jump in our calculator right now. But I mean, we could try and simplify this as just be careful, 276 over 2. This is going to be 323.32. This is going to be 302 over 2. Hopefully I'm not making mistakes. So this is going to be 156. And this is going to be 138. And I mean, I could try and pull this off without calculator, but you do have a calculator. 10, 16, carry the 1 to 11 is 12, carry the 1 to 5 is 6. So this is 1/4. Don't forget the 1/4. That is from the mean value theorem. We can say, all right, 313 over 2. So, 313 over 2. And, I mean, we could put this in our calculator too. 313 over 2. I made a mistake somewhere. 138, 50. Oh, this is 151. So that's 911. Add 1 to 11 is 12. This is supposed to be 621. Anyways, so the dangers of trying to impress someone or something. I don't know. So the answer is 155.25. The units are, this is average weight, people waiting in line. So this is people. And this is an estimate. It's an approximation. It's not a rate. Okay. C says from 0 to 9, what is the fewest number of times at which L prime must equal 0? Give a reason for your answer. So when I saw fewest, I was thinking like extreme value theorem. But it says 0 to 9 was the fewest number of times that L prime must equal 0. Fewest times L prime equals 0. 0 to 9. Okay, so the idea here is that this is relying on mean value theorem for derivatives. And so if we take the slope between any of these points, here the slope's positive, positive, then negative. So it goes from a positive slope, and it could be doing all kinds of other stuff in between, to a negative slope. And so it had to go from a positive slope to a negative slope and being twice differentiable. That means it had to equal 0 at least once somewhere in between here. So it's kind of like a intermediate value theorem. If it goes from positive to negative, it had to equal 0 at some point. So the explanation for it, I'm just going to show you what I wrote down. L is continuous, so it has a relative maximum on 0 to 4. Since L3 is bigger than L1 is bigger than L0, and L3 is bigger than L4, there is a relative min 3 to 7. So just saying that there must be a peak. I don't even know if this would be the best explanation of it, but I'm kind of thinking I would go with more of like the average slope. The average slope must happen at least once there and one there, and then intermediate value theorem has to equal 0. But I'm going to go ahead and, for the sake of time, I've already spent 70 minutes on this assignment. Oh yeah, here's the explanation I was going for. So I have two of them. If you look in the notes, L is differential, so the mean value theorem applies. L prime average equals 56 over 3 from 0 to 3, which is positive. And then from 3 to 4, it's negative. And so at some point, the actual slope had to be 56 over 3. That's just the mean value theorem for derivatives at some point. And it had to be positive. It had to be negative. From 4 to 7, we're going all the way 0 to 9. From 4 to 7, it goes positive again. So then it had to be positive, and then it goes negative again. So from positive to negative, it had to be 0. Negative positive had to be 0. Positive negative had to be 0. So we'd say 3 times, at least 3 times. It could be doing more times. And I mentioned right here, intermediate value theorem. So it's kind of a pain to explain. And I don't know. I don't feel like we've really done the rate model yet. The rate at which tickets were sold. Oh, okay. So there's people waiting in line. The rate at which tickets are sold. So now they finally give us the rate at which tickets are sold. From 0 to 9 is that per hour. Tickets per hour. This is kind of a tough problem. Based on the model, how many tickets were sold by 3 p.m.? Round to the nearest whole number. So, well, that's just integrating this rate. If we integrate the rate, it tells us the change, and that would be the total ticket. So, from by 3 p.m., remember 0 is noon. So 0 to 3, and then round to the nearest whole number. So I'm not going to enter this Y menu because it's a one-time calculation. So math 9, 550 e to the negative x over 2, close parentheses, comma x, comma 0, comma 3. And we get 854.55682338. So, did I do that? Yeah. Okay. So on my solutions, I might have the wrong thing, but there were, it says to round to the nearest whole number, 855 tickets sold by 3 p.m. All right. There you go. Check out C on the solutions.